Welcome everybody to another Inventor tutorial. My name is Mr. Galindo. Today we're going to be adding another program to our setup for the left hand side of our car manufacturing. So this is where we have to start thinking about what we're doing with the materials. We've got a rather large amount of stock here that we don't really need. If you look, we use about less than half of it. And so because of that, what we should be doing to reduce the wear and tear on our machine and also to investigate other programs is running what we would call a roughing code. The roughing program is designed to remove a large amount of material accurately and not go too close to the material that you want to be there at the end, like the finished product. So it leaves a bit of excess that you've then got to remove with what we call a finishing program. Now, if you hover over the milling options, they actually give you some really interesting information about it. For example, pocket clearing, which is the roughing strategy we're going to use, you can see talks about is a conventional roughing strategy for clearing large quantities of material effectively. The part is cleared layer by layer with smooth offset contours, maintaining climb milling throughout the operation. Now, I haven't explained what climb milling is, which is fine. It's more than we've got time to go into in these classes, unfortunately. But effectively, pocket clearing is what we're going to use as a roughing procedure. And now, the setup and the tool all stay the same because it kind of saves it. All we've got to do is specify a few things, such as the boundary of where it's going to remove material and the offsets again. So let's select the machine boundary, and we're going to go selection, and we're going to select the top surface of our stock. So this is the left hand side, so we select this top surface of our stock. We're then going to make sure the tool containment is centered on boundary. If it's inside the boundary, you'll notice that the image here, the circle there, is inside that boundary shape, so it's slightly inside. The centered means that the center of the bit, the cutter, will move over and onto the boundary but not across it, and outside, obviously you can see, will go to the point where the outside of the cutter is always at the maximum outside the boundary. It won't go away from it, but will be outside. We use the center because it stops it from going over and into our fixtures. Now, I'm going to go heights here, and I'm going to select the clearance height. Again, it's exactly the same as last time, 2.5, and the bottom height again is also exactly the same as last time. We're going to go an origin of minus 4 millimeters, and you can see that kind of looks like so. We're then going to go to passes, and this is where we specify the details of this program. Basically, we're going to do a manual step over, which means a step over is how much the bit will move over every time it goes past the material, how much of a chunk it will cut out. We're going to step over about 2.4 millimeters, which is how much you should be doing for about a 6 millimeter ball mill. And then we're going to specify a minimum step over of 2 millimeters because we want to try and do this really fast. If we have a smaller number there, it'll do lots of small, neat step overs, but we want just big ones to get it all done. We're then going to make sure the direction is both ways. Basically, that means it will cut both directions in our balsa wood, which is fine. If we're doing something like iron or aluminium, we wouldn't want to do that because it would affect the finish of that tooling. Now, finally, I want to make sure that the step down, the maximum roughing step down, is 10 millimeters, not 1 millimeter. If you hover over and ask what it says, it gives you some interesting information, but basically the bit is going to go down and then machine around a lot, and how much it goes down towards the center of our block is based on this maximum step down. And we want to go down by about 10 millimeters. We could go by more, but that's a good number for us. It's a nice safe amount. Okay, having done that, we're then going to go to and everything else obviously here should be pretty much done. Please make sure you check this. I'm just going to check my geometry is correct, and it is. Going to select OK, and you'll find that there's now a percentage here next to where it says pocket 1. What that is the program inventor writing the code that will give the machine instructions, and it's a lot more complex than just a drilling cycle, as you may have noticed. Okay, so let's simulate this just so you guys can get a bit of a view of it. Basically, you'll notice that the cutter goes down a certain amount, and then it drills out in passes, you can see these step overs here, and that distance between the two lines of blue is what the step over is about. The step down is how much it goes down and then machines around. What it's going to be doing is actually trying to connect the little components here until it can machine in one pass all the way around and get a lot of material removed. And all we're doing is trying to remove material so that there's less in the way when we do the finishing pass, because then we can go and do that finishing pass very fast. I'm going to speed this up with the speed up option, and I'm just going to have a look at it and check what it looks like. It looks pretty good. You can see how a block is turned into an object that we've designed. And obviously that's very rough looking, and this is where we're going to go now and do a parallel pass, which will be our finishing program to make sure that it's really accurate. Okay, well done for machining and creating your first roughing pass, the pocket pass. That's finished. Thank you for listening.